binary ionic compounds, or compounds composed of ions of two different elements, one of which is a metal and the other a non-metal. The compound formed by this transfer is stabilized by the electrostatic attractions or ionic bonds between the ions of opposite charge present in the compound. So please take note of the chemical formula of the ionic compound that was formed here. It's NaCl, or sodium chloride, commonly known as table salt. You can actually use the periodic table to predict whether an atom will form an anion or a cation, and you can often predict the charge of the resulting ion. Elements of many main group metals lose enough electrons on the left side of the periodic table to leave them with the same number of electrons as an atom of the preceding noble gas. To illustrate, an atom of an alkali metal, group 1A, loses 1 electron and forms a cation with a positive 1 charge. An alkaline earth metal, group 2A, loses 2 electrons and forms a cation with a positive 2 charge, and so on. Just like lithium here and sodium in the previous example. They both lose 1 electron and forms a cation, since they belong to group 1A. The elements on the right side of the periodic table, the nonmetals, gain the electrons necessary to reach the stable electron configuration of the noble gas after them in the periodic table. Atoms of halogens, or group 7A, gain 1 electron and form anions with a negative 1 charge. Atoms of chalcogens, group 6A, gain 2 electrons and form ions with a negative 2 charge, and so on. Like fluorine in this example and chlorine in the previous example. They both gained 1 electron and forms an anion since they belong to group 7A. Lithium atom originally has 3 protons and 3 electrons with 1 valence electron, while fluorine atom has 9 protons and 9 electrons with 7 valence electrons, or 7 electrons in its outermost shell. They're both neutral atoms. Lithium readily loses its only valence electron, and fluorine receives it. This results in a lithium cation, still with 3 protons but just 2 electrons now, giving it a positive 1 charge. Fluorine, after receiving 1 electron, becomes a fluoride, an ion, still with 9 protons but with 10 electrons now. Lithium and fluorine form another ionic compound. The binary ionic compound, which is composed of ions of 2 different elements, one of which is a metal and the other a non-metal. Again, the compound formed by this transfer is stabilized by the electrostatic attractions or ionic bonds between the ions of opposite charge present in the compound. And the chemical formula of the binary ionic compound formed in this example is LiF, for lithium fluoride, which is a colorless solid that transitions to white with decreasing crystal size. Although odorless, lithium fluoride has a bitter saline taste and has a structure analogous to that of sodium chloride, but it is much less soluble in water. It is mainly used as a component of molten salts. Other monoatomic cations that can form binary ionic compounds are the transition metals and some other metals found in this table. They often exhibit variable charges that are not predictable by their location in the periodic table. They are the elements in the middle. For example, copper, or Cu, can form ions with a positive 1 or positive 2 charge, and iron, or Fe, can form ions with a positive 2 or a positive 3 charge. Please check the sample problem on the composition and formation of ions. Please remember that magnesium's position in the periodic table, group 2A, tells us that it is a metal. Metals form positive ions or cations. On the other hand, nitrogen's position in the periodic table, group 5A, reveals that it is a nonmetal. Nonmetals form negative ions or anions. Let's start using these ions in writing chemical formulas for the binary ionic type of compounds. In order to write a chemical formula using charges or valences, you need to know which elements are in the compound and their corresponding charges or valences. Take note that in every ionic compound, the total number of positive charges of the cations equals the total number of negative charges of the anions. Thus, ionic compounds are electrically neutral overall. The net charge should be zero, even though they contain positive and negative ions. We will use this to help us write the formula of an ionic compound. In the previous example, lithium fluoride LiF, lithium ion has a charge of positive 1, while fluoride ion has a charge of negative 1. Because there is one of each ion in the formula, the sum of the valences is 0. These oppositely charged ions are usually produced when a metal transfers its electron to a non-metal. Take a look now at the sample problem on determining formulas of binary ionic compounds. Please be reminded that ionic compounds are neutral. We find the smallest number of each